So here we have our battery data. The first thing that we can see is that we have three columns: the participant ID, the group we've allocated them to, and then the result from the diary as to the number of hours each battery lasted. Let's go to the variable view to see how this has been set up. Firstly, we have the group variable. Within this option called values, let's just have a look at how I've set this up. Now I've told SPSS that a value of 1 refers to those who receive standard batteries, whereas a value of 2 is those who receive the green batteries. I've also told SPSS that this is a nominal measure. This is just a name that I've given to each group. In contrast, for hours, the dependent variable, it's a scale measure, and that's important because in theory, the battery could have lasted any number of hours, whereas for group, you could only receive standard or green batteries. Going back to the data, we can see that there are 20 who took part in group 1, i.e. they received the standard, and 20 who took part in group 2, i.e. they got the green batteries. So let's check if the data is normally distributed, and we'll first do this using some histograms. If you select Graphs, Legacy Dialogues, and at the bottom there's an option to select histogram. Your hours is your dependent variable, so move that over here. You always want to check Display Normal Curve, and then your group we're going to select into the column option. Select OK, and that will run and produce the output you see on screen. So this is where we have to subjectively interpret this. For the standard group, just looking at this, the normal distribution curve does appear to follow our peak and trough fairly well. For the green group, we can see that the peak number of values happens slightly to the right of the normal distribution curve. What we need to do next is to look at this using some statistics, for example, the Kolmogorov-Smirnov test. To get this, select Analyze, Descriptive Statistics, and then select the Explore option. Like before, our hours is our dependent variable, so moves into the dependent list, and our group is the factor which we want SPSS to split them by. Within plots, please select normality plots with tests, and that will give us the Kolmogorov-Smirnov statistic. Select Continue and OK, and we'll get those results on screen. First of all, we have a summary with the number of cases SPSS has looked at. 20 is correct. And then a descriptives table per group, so standard and green. We have the mean, median, standard deviation, skewness, kurtosis, etc. per group. And then here we have the tests of normality. In this case, we can see that the KS test has a significance value for both groups that is above 0.05. So we can conclude that despite the histogram for the green group looking abnormal, that both of these groups have data which is normally distributed. We can now go on to perform the independent t-test. To do this, select Analyze, go down to Compare Means, and then across to select the independent t-test. In this case, the hours is our test. Variable view earlier, that group 1, standard batteries, were given a score of 1, so we'll put a 1 there, and group 2, those getting green batteries, were given a score of 2. So we'll input that here. Select Continue, and then OK to run the test. It's probably worth noting that you should check the Options tab just to make sure that your confidence interval is set appropriately. Select OK to run, and that output will come up at the bottom. Again, it gives us a summary of the descriptives, for example, the number of cases per group, the mean, standard deviation and standard error. It also gives us something called the Levene's test, which tests for the equality of variances. A Levene's test of greater than 0.05 significance means that the assumption of homogeneity of variance is present, and we can interpret the top line of the table. If it's not, if it is significant, say less than 0.05, it means that equal variances are not assumed, and we should only interpret the second row of the table. In this case, Levene's significance is 0.175. That's well above the 0.05 cutoff, meaning that equal variances are assumed, and we can continue to interpret just this top line. Moving across, we can see in the significance value that there is a significant difference between the means of each group, denoted by this significance value of less than 0.0001. Looking at the mean difference, indicated here for the groups, we can conclude that the green batteries lasted on average 2.85 hours more than the standard batteries, and that's based on the means which we can see here. This represents a significant increase compared to the standard, and so we can conclude that green batteries do last longer than the standard batteries in this experiment.